Hello, everybody. Glad you're here. Today we're going to talk about operators in the order of operations, starting with operators themselves. So the reason we need to talk about any of this is because we're here to talk about how to successfully and correctly do calculations and deal with numbers and math in business. Operators are a fundamental part of dealing with numbers and math. So operators are symbols. They are used to join numbers together in formulas and equations. Those things are more generally called expressions. And here are some examples of those. So a mathematical expression could include numbers, it could include variables, it could include operators, and somebody might call it a formula, and another person might look at it and call it an equation. An expression is the most general way to talk about that kind of thing. Operators are used in Excel to join cell references in formulas and expressions. So we're going to start talking about Excel in this unit. We're going to talk about cell references. And for right now, just think of cell references as numbers. So operators in Excel join numbers together also. It's just numbers go in cells in Excel. So the operators join cells together in order to do mathematical operations. You'll see I'm making it sound more complicated than it is. Mathematical operators, though, in particular, symbolize certain mathematical operations that need to be done. For example, the addition operator, which is the plus sign, right? You see it right here. In the expression 90 plus 7 indicates that 90 and 7 should be added together. So the plus operator tells you that the mathematical operation of addition has got to be done with the two numbers on either side of the plus sign. Table 2 shows some of the common mathematical operators that you will encounter in the study of business. There are examples in the third column of these operators in common usage. Because the thing is we have many different ways of saying equal, for example. We have many different ways of saying divide or division, of indicating division in language. But division is just one thing in math, although it can be symbolized in multiple ways. So, taking a look at this table 2 of mathematical operators, we see that some of these operators have only a single symbol. All of these operators are only a single operation. So what I mean is, if we take a look at the multiplication row, you see that multiplication could be signified with an X, with a dot, or with an asterisk. So 2 times 4 could be 2 dot 4, or it could be 2 times 4 with an asterisk. The asterisk is the one that is used in Excel. Okay, and 2 times 4 with the X symbol is probably the earliest representation of multiplication that you learned in your life. So these operators, these operations, they are singular operations, but they can have different symbols. Of course, there are even more ways to write these operations than what is indicated in this table, because as we see in this paragraph, you know that 2 times 4 could also be indicated like this or like this. These are common ways. So using parentheses where the 2 and the 4 are brought together with parentheses with no operator in between indicates multiplication. Exponents can be indicated with a caret. So 2 to the 4th could be written like this. And in fact, this is the way that you would write it in Excel, or type it in Excel. And 2 to the 4th could also be indicated like this with a superscript. This is the classical sort of like mathematical way to show exponentiation or raising something to a power. So this is 2 raised to the 4th power. It equals 16 no matter how you write it. So mathematical operators connect numbers together in mathematical expressions. And when those expressions are complicated, there may be more than one operator to deal with. In fact, when they're complicated, there is definitely more than one operator to deal with. In order to evaluate those expressions properly, you have to use order of operations. You have to know the rules about order of operations. You need to know which one you should do first, because specifically in business, it's no longer going to be about getting a math problem wrong. If you don't account for order of operations when making calculations and dealing with numbers, you're going to get the wrong answer, and that's going to lose you money. A lot of calculations in business have to do with deciding whether or not to pursue new opportunities. If you do them wrong, you may not pursue an opportunity that you should have done, or you may pursue an opportunity that you should not be doing. So these things have concrete real-world implications, and so we're going to go over order of operations to analyze mathematical expressions, to deal with them and calculate them properly. Then we're going to talk about how those order of operations translate into Excel, because that's where most of your calculations are going to take place. That or a calculator, which works much the same way. So order of operations is important because it prioritizes each operation so that there is only one correct way to evaluate the expression. Figure 2 shows the order of operations. So this is giving you the priority from upper left to lower right. Parentheses are at the upper left. The deal with parentheses is they're not quite like the other operations. What they do is force the order. So anything enclosed in parentheses has to be done first, no matter where it appears in the expression. Other than that, you follow the basic idea outlined in this paragraph. To evaluate a mathematical expression, start with the leftmost operator in the expression that has the highest priority. Evaluate that operation first, then proceed to the others in descending priority order, proceeding from left to right within the expression. When two operations have the same priority, like multiplication and division, evaluate the leftmost one first. So in this diagram of order of operations, you see that parentheses is alone in its bubble, but the next bubble says exponents and square roots. Exponents and square roots actually are the next highest priority, and they're actually the same thing. So I'm going to scroll down to this little footnote I have here. So you may wonder, why are square roots in with the exponents? In math, the square root symbol is actually another way of representing the exponent 1/2. So exponents don't have to be whole numbers. They don't have to be positive numbers. They can be negative. They can be decimal numbers. They can be fractions. And specific fractions refer to the roots. Okay, so the square root is the 1/2 exponent. It's the same thing applied to the quantity under the square root. So for example, if you had square root 4, that could be written as 4 to the 1/2 power. Both of those equal 2. It works the same with cube roots, like cube roots are to the 1/3 power. Fourth roots are to the 1/4 power. So the 2 is where that square in the square root went. So that's a lot of words in abstraction and directions. Let's apply this set of directions to example 2.1. Example 2.1 says, use the order of operations to evaluate the expression 4 squared plus 55 divided by 11 divided by 5 minus 14. So, your blood might already be freezing at looking at something like this. It's okay. We're going to be able to look at it together. All right, so taking a look at this expression, because I'm going to do this by hand, I'm going to rewrite it so that I have a nice space to work with. So 4 squared plus 55 divided by 11 divided by 5 minus 14. We are asked to evaluate this expression using order of operations. All right, to evaluate a mathematical expression, start with the leftmost operator in the expression that has the highest priority. Okay, so looking at this, we have an exponent here, we have some divisions, and then we have an addition and a subtraction. And by the way, whenever the bubble has two operations in it, they are at the same priority. Same priority. So whichever one you hit going from left to right first is the one you do first. All right, if they're in the same bubble. So the highest priority operation that I am looking at here is the exponents on the 4. So we're going to do this operation first. 4 squared is 16. You can use a calculator for that if you like, or you might know that. Squared just means 4 times 4. So 4 times 4 is 16. I'm going to write out the rest of the expression because we only solved the exponent in this pass. Okay, next order of priority. Well, looking at this, parentheses, there are none. Exponents we already took care of. We've got multiplication and division. So I see a division. Which one do we do first? The one on the left. So you're going to do this operation next. 55 divided by 11 is 5. Now I'm going to recopy the rest of this expression so we can keep track of what we're doing. So now we have 16 plus 5 divided by 5 minus 14. Okay, now what do we do next? Well, we have another division going from left to right. 16 plus 5 divided by 5. Okay, so we got to do this division next. 5 divided by 5 equals 1. So now we have 16 plus 1 minus 14. Now when we look in our order of operations, we see that addition and subtraction are in the same bubble. So they have the same priority. So you just proceed from left to right. 16 plus 1 is 17. This plus happened first, going from left to right. So 16 plus 1 is 17, minus 14 equals 3. Next, we are going to work through an example using order of operations correctly when there are parentheses present in the expression. So we'll be following our order of operations that are in figure 2 in order to process the expression in example 2.2. So parentheses have the highest priority no matter where they occur in the expression. They're used to force the enclosed part of a calculation to be done first, no matter where it occurs within the expression. So the way you handle them is if the expression you are evaluating has parentheses, find the innermost pair, evaluate what is inside those, and within the parentheses, you just perform operations according to the priority in figure 2. Then move on to the next innermost pair of parentheses and evaluate what is inside those. And you keep repeating that procedure until no parentheses remain. So taking a look at example 2.2, it says use order of operations to evaluate the expression 27 divided by, and in our first set of parentheses, we have 1 plus, then another set of parentheses, enclosing 2 times 4, close parentheses, minus 2. All right, so I'm going to rewrite the expression so that I can manipulate it more easily with my pen. So let's do that. The innermost set of parentheses are these, enclosing the 2 times 4. So that is going to be the first expression we're going to deal with in evaluating this entire mathematical expression. 2 times 4 equals 8. So now we have 27 divided by, open parentheses, 1 plus 8, close parentheses. So notice my pink parentheses, they're gone now because we have the 8 that actually those evaluated to. So 1 plus 8 still remains inside this outer set of parentheses, minus 2. Next thing we have to do is evaluate what's inside the parentheses because parentheses remain the highest priority operation. So we're going to evaluate, since there's only one set of parentheses, I'm not going to highlight them in pink, but we're going to evaluate this expression 1 plus 8, and we get 9. So now we have 27 divided by 9 minus 2. And notice that plus, it becomes higher priority essentially than the division because it is enclosed in parentheses. So the addition had to happen before the division. So this is an example of what parentheses do. They force operations to be in a certain order. In other words, they can override the usual order of operations. So now we have 27 divided by 9 minus 2. The highest order of operation that is present here is this division, 27 divided by 9. And notice I'm continuing to scan this from left to right every time I'm going from left to right. So 27 divided by 9 is 3 minus 2 equals 1.